Good, starting to work. Okay, so just a quick introduction to syntactic and semantic conversion. Why are we doing this? Well, if we want to utilize assets, we need to understand their characteristics recorded as metadata. There'll never be one universal metadata standard due to lots of differences, not only subject domain, but also different levels of detail and different purposes. So we're always going to have to be able to convert between different metadata standards for fair purposes, and following that, asset instances to an agreed common format so we can utilize them together. Many of you have heard me say this before. The problem is the combinatorial explosion. If we relate every metadata standard to every other, then we've got basically an n squared problem. If we relate every metadata standard that's relevant to just one rich superset metadata standard, we have an n converter problem, which is therefore tractable. So the fewer standards we have, the better it is for interconversion. Syntactic conversion is covering the structure of the metadata, which can be in many forms, and the attributes within that structure. The little table shows one example from the library people of converting Mark 21 to Dublin Core. And as you can see, there are 6 elements in Mark 21 that convert to one DC element. And at the very bottom, you can see that there's one DC element, creator, for which there is no Mark 21 equivalent. So we have a real problem here, and this is very typical of the problem of syntactic conversion in metadata. Specifically, we have to deal with repeating groups and missing equivalent attributes, which can lead us to problems of both referential and functional integrity from extended set theory, which I'm sure you all know well. So that means the converted metadata may not represent accurately the real world, and therefore using it as the basis for conversion of the underlying asset instances is liable to be erroneous. So here's an example. The green one is a hierarchic structure, and this is a fairly typical metadata structure. This is an oil well with attributes. It has a stratigraphic layer entity with attributes, and attached to the stratigraphic layer, one for one, you have geochemical information and geophysics information. And then separately attached to the oil well is the downhole instrument, the thing you drop down the well, picking up readings as it goes down. And those readings are, as you can see, the geophysics reading of resistivity and radiation. So a typical hierarchic structure to deal with, and only of limited complexity. The red one is basically the same thing, but as a graph structure and adding a lab instrument at the right. That is that the geochemistry and geophysics are measured by some kind of lab instrument. Here you see you've got a graph, i.e. a fully connected graph structure. So the point I'm making is that metadata can have complex structure if it is going to reflect the real world accurately. The next problem is that the real world is defined by the researcher observing it, and so you can get different kinds of metadata structures for the same worldview. Within a domain, or even across domains, it's good for interoperation to converge to a common format if possible. And then there's 2 choices, subset or superset. Subset format has maximum population of attribute values, but with minimal richness and minimal interoperation. And the superset format accommodates everything, but with a lot of missing information, of course. And throughout, you have to maintain referential and functional integrity. End of syntax, onto semantics. This is a bit shorter. Semantics typically is represented as a term-to-term relationship. The relationship typically in a thesaurus structure is something like a superterm or a subterm, synonym, antonym, and so on, or in advanced technologies, any logical expression, including modal logic, probability, saying this term is related 90% as a superset to this other term. So we have 2 major problems. First one is context. If you take the lexical 4-character string BOND, you can see in different contexts, it has completely different meanings. The second problem is multilinguality, not only translating from one lexical string to another lexical string, but also due to cultural changes, then you get the standard and well-known problem that the Inuit have 50 terms which translates to the English snow. There are a few more terms for snow in French, and there's the apocryphal story, of course, that the French have 8 terms for stomachache. So the take home, there's a lot of work to be done, but we shouldn't be too downhearted. Some example systems have been working for years, so indeed it is possible. If we're going to interoperate research assets, this work is an essential prerequisite. It's intellectually challenging, it's a lot of fun, and it really, really assists researchers in doing their work, so it's important. And a little plug for Alex for later on, metadata schemas and some conversions are available at the output from the Metadata Standards Catalogue Working Group. It's hosted at Bath in UK. Thank you.
Okay, thank you, Keith. What we're going to do now is we'll go through some
Well, I think I've stopped sharing. Can you still hear me?
Yes, we can hear you. So we're going to have some presentations on some existing syntactic and semantic conversion methods. So next up is Mari, and she'll be showing her screen.
Oh, well, thank you, Rebecca, and hopefully I will be showing my screen. No.
There.
Okay, great. Thank you. Sorry for that. Good afternoon, everybody. My name is Mari Kleemola, and I'm from the Finnish Social Science Data Archive that is part of SESTA. And I'm here to give you a short 5-minute presentation on the work we are doing in the SHOC, Social Science Humanities Open Cloud project about conversions. I'm not going to go into detail about SHOC, but there's some information there you can look at after the presentation. So in SHOC, we have a task about metadata and data format conversions. It's called Interoperability Hub in the task description. Basically, what we are doing in this task are 2 things. So we are building a conversion hub that's a place that includes descriptions of conversion solutions, mostly between metadata standards or metadata formats. And the second thing we are doing are the actual metadata format conversions themselves. So we are developing a bunch of those based on the use cases we have from the social science humanities community. And all this has been reported in deliverable 3.1, and there's a link to that in my presentation. So what are the solutions that or format conversions we have recognized? I think we had something like 44 solutions in our inventory list, and there are different kinds of solutions for this format conversion. So there are already existing, accessible, ready-to-use services that the researcher can easily use. Not too many of those, but some. Then we have a lot of things that we call at the moment like installable software. So something you can install, something you can use, but you do need to have a certain level of knowledge there, and you need to have rights to install something on your computer, for example. And then we have something we are calling complex solutions, or we are calling them recipes. So there are steps you need to take. There might be, you might need to use several conversion services or software to get from point A to point C. So these are the kind of things that we are dealing with. This is social science and humanities. We have a limited number of conversions. We have a limited number of metadata formats, but it's still huge, the number of metadata formats in use at the moment. So the conversion hub, I have a couple of pictures. It's still work in progress. You can go and see what's there, but just keep in mind that it's evolving, and well, sometimes it might be down. I will say a couple of words about the conversion solutions themselves. So we envision that the researchers could be the users, but also infrastructures, especially for the more complex ones. I can see that the infrastructures would be the main users. We are very much focusing on syntactic interoperability because, well, you have to start somewhere. We are aware that this is just a small part of the whole landscape. We are also we see that all these metadata mappings and crosswalks, typically they are what I would call, as a social scientist, I will call that they are at the study level or basic findability, and you do need these fine-grained domain-specific formats. There are a lot of question marks after shock, maintenance of the whole conversion hub, but also the solutions there. So there's a lot to think about, and I think that's something we can discuss also in our this session. So this was basically very shortly from the shock metadata conversion side. Thank you.
Thank you. Okay, next up is Don, and I'm assuming you'll be doing your slides, right?
If you want, I can share my screen. I can try to share my screen.
Okay, if not, I can do them for you, but why don't you try it first?
Yeah, okay. Doesn't seem to do a lot. So maybe Rebecca.
Okay. I'll share your slides. Just one moment.
Okay, great, thank you. Well, maybe I can already start.
Okay.
Hello, good afternoon. My name is Dan Broeder. I'm affiliated with the Claire and Eric. I've got lots of experience in metadata and converting metadata. So I know it's a matter of both syntactic and semantic conversion. Often these things, I think, are not too, you cannot tell them apart. They're part of the same technology. But that's maybe interesting for the discussion after this. So next slide, please, Rebecca. Yeah, thank you. So, yeah, thank you for the opportunity to explain a bit about the Semap project. Semap is a study supported by the EOSC Secretariat, a study that wants to look at current practices for semantic mapping by the different communities, look for requirements, and make a proposal for what we call a flexible semantic mapping framework. The people doing that study, the authors, have already quite some expertise among them, but they also did 25 interviews with community experts. We submitted our final report end of last month, and it was acknowledged by the Secretariat. We'll see what comes out of it. You can download it. The link is in the presentation and also in the notes. Next slide, please, Rebecca. Yeah, what is essential about Semap, about the study? Well, one thing we found, we already thought it was, otherwise we wouldn't have started this, that the current semantic mapping practices are pretty fragmented and insufficiently documented. And to counter this, our proposal is to register and host semantic mappings with proper metadata and provenance in what we call FAIR Semap registries. Semantic mappings should be fair, first-class citizens, so they should have the same regards and infrastructure associated with them as other digital objects. To promote the use of these Semap registries, Semap should also offer easy to use graphical user tools for end users to help them create new mappings, but also to reuse and extend existing ones. Sharing is an important part of the proposal. Semap is pragmatic. It's targeted at solving specific interoperability goals. So for instance, if you need to create mappings between a few entries of two different vocabularies, you shouldn't be forced to create a complete mapping between those vocabularies, but only solve the problem at hand. Semap is flexible and inclusive, so we want to be able to integrate existing semantic components, and by integrating them in the registry, make them fair. We don't want to force any specific technologies, but rather recommend the latest ones by offering suitable tools that work with these new technologies. Semap should be integrated in EOSC for governance and sustainability. Next slide, please, Rebecca. Yeah, so I think one of the important outcomes of the study that we did was that the Semap proposal can be attacked in several tranches, as it were. So the majority of the communities I interviewed, for instance, said that they would already be very happy if there would be a registry system where we could have proper metadata and provenance for the different mappings. That would already be very useful, because currently they are either using something that's only suited within a project group or even one community, but there is nothing cross-community. That registry should be inclusive and support registering both external hosting mappings and internal ones. And the added value for the registry type of hosting of mappings should then be better provenance tracking and uniform accessibility management. And potentially there could be several of such Semap registries, and maybe they do not all need to deal with semantic interoperability, so the semantic mappings, but there could be other type of mediations. As long as they are in the same framework, they should work together fairly well. And we are talking to the brokering working group to make sure that the requirements are consistent in that respect. Next slide, please. And there I only want to mention 2 points. One is the well-described APIs. As I already said, we want to be inclusive. So we want to allow the integration of community tools, and for that we need a well-described API. And secondly is the technology and standards to be supported. We have noticed there is, of course, a large variety of mapping specification and technologies out there. Including human readable text and tables. And I think we should still support these. And next to that, there are, of course, XSLT sheets, which are, I would call them a mixture of both syntactic and semantic mappings. And then there is RDF, but much less than you would expect of, let's say, that technology. And that concludes what I had to say. Please download the report.
Okay, thank you. Right, next up is Maria. Are you ready to go?
Let me share my screen. Okay. So, good afternoon. I am Maria Theodoridou. I'm affiliated with the Foundation for Research and Technology, Hellas, Fourth, in Greece, Crete. And I will present the X3ML toolkit something that we have developed several years now and use quite extensively to support the data aggregation and integration process. Initially, we started, our motivation came from the cultural heritage domain, but during the years we used the tool in other domains, and we've realized that data aggregation and integration has the potential to create rich resources useful for many different applications for different purposes, from research and data modeling to education and engagement. So there is several tools needed in this process, from modeling, cleaning, normalizing, and transforming. And what I'm presenting is actually the transforming part. Among our requirements, what was really very important, and I think Keith mentioned a lot about these problems that exist in mapping, but the important thing is to preserve the existing information, if possible enhance it, but certainly what we don't want is to lose information. So mapping from one schema to another, we have to make sure that the important information is there as it was at the source. I will briefly show you the workflow, and better stay with a specific example. We can have different sources of information, heterogeneous sources. For example, here we have a document database, an archive, or an image database, possibly a gazetteer for places. And then all these will go through the transformation tools, our tools, to map the source schemata and end up in the aggregated database, which is, here we have semantic integration, of course, and we use a specific target schema, one common schema for everything. In this case, in this example, it's CDOC CRM, but this is not limited to one schema. It can be anything. We just have to choose our target schema and go through this workflow. So the toolkit is a set of small open source microservices. They are designed with open interfaces. Everything is open source. It is easily customized and adapted according to the application. And as I said, it assists the data provisioning process. It uses X3ML, which is the mapping definition language, and some tools, editing tools with user interface, and the transformation engine. The language itself is very simple. It's XML-based language, declarative language. It can be even edited by somebody that knows well XML. It could be edited directly, but of course this is not the point. And it allows collaboration. So we different experts can collaborate to create the mapping, because we need experts that know very well the source schema, and we also need experts that know very well the target schema. We have the editor that helps. It's a graphical user interface and helps the user to create the X3ML. The user doesn't need, it's transparent, he doesn't need to know about X3ML. The editor will help and will try to restrict the user so that he doesn't make mistakes. We are now almost ready to launch a new editor with a new user interface, more modern and using responsive technologies. The engine, the X3ML engine, is the final tool that does the actual transformation. So according to the definition of the mapping, it transforms the data from their original format to RDF that follows the target schema. Up to now, we have used this system, this toolkit in several European projects, also in local Greek projects. But here you can see some of the big Horizon 2020 projects that we have been using this technology. As SOC that Marie presented has used has been using this. Ariadne Plus and Silit, the British Museum also is using it in research space. Some of the advantages of the toolkit is that it has a very simple model for defining the mappings. It supports incremental changes of source and target schemata. It supports customized URI generation policies. Decouples the schema mapping from the URI specification, and in my opinion, this is the most important feature. It is easily deployed in different contexts and promotes collaborative work. On the disadvantages, I would say that currently it only supports XML to RDF transformation, so we need to have the source in some kind of XML. So, okay, we can start from Excel and make it XML, but yeah, it has a fairly shallow learning curve, and especially the URI specification needs some people that have technical skills. It cannot be done by only the domain experts. And we do have a problem of scalability going to really huge data sets. For small and large data sets, we're okay, but on big data, we still have some problems. Here I have compiled the links to GitHub and everything where you can find the code. And this is it from my side. Thank you very much.
Okay, thank you. John, I hope you're here. John Graybill?
I am here.
Wonderful. And I'll let you do your slides because you know how fast you want them to go.
I will try to do my slides. We'll see how the technology supports that.
Okay.
So tell me if you are seeing my slides.
I see your slides.
Excellent, golden. To talk about CEDAR in our context of modifying and mapping and so on metadata, I first have to describe CEDAR a little bit. And it was really designed with this idea of standardized syntactic and semantic metadata in mind, including using data structure standards and existing assets as well, and to make that really easy for users to do. So CEDAR is really a simple to use end-to-end metadata management system that you can integrate with your systems or use in a standalone way, and principally has the ability to design templates, forms if you like, for metadata, and immediately have those forms filled in by your users for storage in CEDAR or in other databases. So typically template specifiers might be the managers of the project or of the data, and the research scientists filling it in use the metadata editor tool to actually fill things in, all of which is relying on a terminology service that is providing access to semantic standards that are available in the community. So as a practical matter, this means when you're creating your template that you get to specify your fields using drag and drop and filling in aspects of the fields. And then you can associate the fields and particularly the values of the fields by clicking on a search or an add button and seeing a selection of terms from BioPortal that match the particular field. And by clicking on those terms, you can actually see the context of that term in BioPortal, and you can choose either the term itself, the whole branch, or the whole ontology in order to make the selection of what the users can later fill out for their metadata as the terms in the drop-down selection. So by selecting a branch or an ontology in this case, you can actually make it possible to constrain in a very precise way what the user selects, but also can add features for the metadata completion, such as intelligent authoring suggestions based on what other users have filled out for the similar form. And the key thing, as the third arrow here indicates, is that all of these are ontological choices or semantic choices, controlled vocabulary choices from BioPortal. So the model is including the semantic relationships up front and essentially assuring the interoperability by making sure this is not simply a syntactic string of characters that cannot easily be mapped. All of it is captured in Cedar under an overarching model, the Cedar template model, which is very carefully defined and published as a specification, and consists of JSON schema and JSON LD used for the template specification, the schema if you like, and JSON LD for the metadata itself. That's the internal representation. But the JSON LD is carefully designed so that it can be transformed into RDF in the way that JSON LD should be without losing any of that semantic information. So we have a very robust set of APIs and systems that are accessible as open sources, open services, and that make all of that data available through standard functions. And what that lets us do is create workflows, not just in the case of Cedar talking to itself and the users filling out the metadata there, but also other systems integrating with Cedar. So people can use Cedar just as a front end, or they can use it as a metadata storage, or they can use it as a validation system for their metadata. And this creates all sorts of flows that are possible in the Cedar system. The Cedar only workflow then can be augmented in various ways. In this project that we're doing with HubMap, we are doing the conversions on the fly using a reconciliation in a Google spreadsheet context and returning the reconciled metadata back into the Cedar system in a more semantically specific way. In the case of Welcome Trust, in an award we hope to finalize shortly, we are doing a conversion or pilot project that is presenting this metadata system in workshops so that communities can be trained in the production of FAIR metadata using the FAIR data collective tools and the Cedar tools and the metadata for machine tools that GoFair has pulled together into this overall system. So we have multiple projects like these and others that are working with our hypothesis that if we can create this foundation for managing semantic metadata and make that foundation available to any system that wants to interoperate with it, that will let us create much more standardized metadata that's available to any or all people who want to make use of it and transform into that format or out of that format. So the resources will be in the presentation, which I assume will be available later. Rebecca, you can maybe comment on that. Thank you all for the time to present Cedar.
Thank you, John. Yes, the slides are available. I'm putting links in the notes as we go along so people can get to them. Okay, next up is Anna-Lena.
Okay.
Great.
This is my screen. 1 second. Okay. Hi everyone. I hope you can hear me fine. If not, please just interrupt me. I'm here today to speak about syntactic and semantic metadata mapping across disciplines from the B2Find perspective, from the discovery portal perspective. B2Find, in a nutshell, is one of the EUDAT services, part of the DICE project at the moment, which is the data infrastructure capacity for EOSC. We're a simple and user-friendly discovery portal for research data. This gives a joint metadata catalog for records from very divergent research areas and very divergent research infrastructures. All of this based on a very generic, very flat metadata schema based on the DataCite top-level elements. How we work is we harvest metadata from our communities via different APIs. Then we are mapping this metadata, which is mostly format conversion, mostly XML to JSON. We have templates for standard metadata schemas, such as Dublin Core, DataCite, ISO 19139, DDI2, which automatically map the metadata to our B2F schema, including extensive validation and vocabulary mapping. So there we are in the semantic part. Also, we harvest from very small communities sometimes who do not or who make their metadata available for the first time, who are not that experienced, and there we try to curate a little and tell them how to make their metadata more findable and a little bit fairer, a little bit more fair. So after the mapping, the metadata is being ingested into our web portal. There users can conduct a free text search or a faceted search to narrow down their results. A strong point of B2Find here when it comes to interdisciplinary search is the spatial and temporal search options, which you could imagine for COVID cases, for COVID-related research, one of the use cases would have been to get data that is related to the Netherlands or something like that. There, B2Find was helpful. Our challenges. We have to tackle keywords and research disciplines with very diverse vocabularies or even just free text. Sometimes even different ones within one research community when they cannot agree on one vocabulary. So this leads to values in the facets that are semantically very, I'd say, adjacent. Not ideal yet. Then an issue is the multilingual search. It becomes more and more popular within the last years for research communities to publish publish their metadata in their own languages instead of using English as a lingua franca, for example. It's a little bit of a trend there. I don't know if you have noticed that too. Then the issue of granularity of the metadata is always an interesting one for us. It's the question, do we want to publish each single file, or do we tend to make data collections searchable? This also varies from community to community. Definitely difficult to find a common ground there. And an ongoing challenge is our metadata schema. As I said, it's very generic. This was developed to keep the barrier for communities to publish their metadata with us very, very low. We really wanted to get at those metadata silos there. Still, we always question if the information loss that happens with the generic schema is too big. One strong point of B2Find there surely is the metadata access. This is a link to the originally harvested metadata in every B2Find record. Yeah, there you can look up missing metadata at a first glance and decide whether the found data set is right for you or not. One example from IVOA here. IVOA is the International Virtual Observatory Alliance. This is an example from a very specific, very unique standard, the EVO standard, which we're talking about the astronomy here. And there you can see they have spatial parameters, spatial values that that define sky coordinates. This is not possible to usefully map in B2Find. We cannot map this to geolocation, for example, although we have the syntactic element of spatial geo-coordinates. But as I said, they refer to geo, to our Earth surface, and here the meaning is different. So, and then we have spectral, for example, that is an element there for which we cannot find any useful mapping at all in our very limited schema. Some successes that we had, that happens thanks to close communication with enthusiastic metadata managers within the communities. We are big fans of the bottom-up approach. We try to keep in close contact with the single communities, and there are wonderful people there who sometimes in their free time, well, we are at RDA, you know this, who come up with wonderful solutions and ideas, and we, of course, try to incorporate those. I already mentioned IVOA, the International Virtual Observatory Alliance. There we had an understanding. They had very free text keywords on their side and mapped them to the unified astrothesaurus top-level concepts to make them to use a controlled vocabulary there for those keywords. And then B2Find implemented that same top-level concepts of the unified astrothesaurus to map these records that we get from IVOA to our disciplines then. So the B2Find discipline will be the same value as the keyword and the same as the unified astrothesaurus. So that was a nice cooperation, which helps with the findability of their records. And then in the case of EOSC Nordic, we are having a cooperation. We try to establish a place for a Nordic archaeology data, a search space. And there we have the multilingual challenge. We have some keywords in Danish, some in Norwegian. They do not always depict the same, describe the same concepts, the same semantic concepts. So there we are in close cooperation and trying to come up with a multilingual mapping for those archaeological data keywords. The strong point of B2Find, as I said, is the metadata access link to the original metadata with every record. So users can have a quick look. This is just the picture of the unified astronomy thesaurus on the left, the top level concepts and their counterpart in the B2Find's disciplines list on the right, just to illustrate. And then some principal questions I would like to ask for the discussion also is, well, the question we all ask: how can we enable reuse of research data across disciplines? And some points are that finding, accessing, and interpreting data from another research domain can be a challenge in itself. Is what we got as a feedback, and then we always need use cases for successful interdisciplinary data reuse from researchers. We need to establish an ongoing dialogue, I think, and get feedback, but especially as a discovery portal, we are not sure yet how, because we do not get feedback from users. Yeah. As an inspiration for some cross-discipline discovery, I would like to cite the blog here of Markus Demleitner. He has some user stories as they might happen in an ideal future where cross-discipline data discovery and usage are more or less a reality. Those are really interesting to read. So if you have some free time, I encourage you. That is really interesting. Yeah, if you have questions, comments, or remarks, I try to capture all the relevant links. You can contact us if you want your metadata to be findable and B2Find, or for any other feedback. That's it from me. Thank you.
Thank you. And next up in the last presentation, and then we will, there's some questions for the different speakers in the Q&A and in the chat, and we'll get to those as soon as Alex is done with his presentation. Alex?
Hi there. So I'm hoping you can now all see my slides.
Yes.
Fabulous. Okay, so long-term members of the metadata interest group will have heard me talk about the metadata standards catalog before, but for the benefit of anyone here who hasn't, here's just a brief summary. The catalog is the third incarnation of a resource that was originally developed for the UK Digital Curation Centre. It was originally designed to help research support staff at UK universities advise researchers on appropriate metadata standards to use when documenting their datasets. The DCC catalogue was launched in 2013, just as the Metadata Standards Directory Working Group was starting up in RDA. And the working group joined forces with the DCC, first of all expanding the catalogue to make it usable in a global context, and then porting it to GitHub so that it could be maintained by the community. So the Metadata Standards Directory itself was launched on GitHub in 2014. But there were things that we needed the directory to do that couldn't be done on GitHub pages, most noticeably a machine interface for plugging it into other systems. And we wanted to be able to use it for more detailed analysis of metadata schemes with the eventual aim of using it to generate converters between them. So that meant we needed it to be a dynamic web application rather than a static website. So the Metadata Standards Catalogue Working Group was formed, and then over the course of 2016 and 2017, we developed the catalogue as a dynamic version of the directory. Last year, with 3 years of hindsight to help me, I rewrote the catalogue from scratch, and we launched the new version in September. It's still in active development. So there is a new authenticated read-write API that I'm currently testing, and that will be launching very soon, I hope. So as I mentioned, the original aim for the catalogue was to provide a discovery service for metadata standards suitable for documenting research data. And in order to power this, we needed information not only on the metadata standard itself, but also information on how well supported it is, which you can gauge from the number of tools that read and write metadata in that form, any formal endorsements it has, and are concerned today with the mappings that allow you to convert into and out of that standard. So in the context of the catalog, we use a generic term, mapping, but we're including in that a whole range of different things, including tables and spreadsheets in sort of human readable documents that compare two or more metadata schemes side by side, but also tools that can read one metadata scheme and write another, whether that's an XML style sheet transformation, a library written for a given programming language, or executable software that runs on a given platform, or some kind of web application or API. The information we collect about them, we consider the most useful fields to describe a mapping to be the schemes that it maps between, the location from which it can be obtained, the type of which also tells you what kind of mapping it is, and any identifiers by which it is known. But of course, we want as much information as possible, so you can also specify who is responsible for the mapping and describe any nuances that potential users should know about. The description and the links show up in the records of each metadata scheme supported by the mapping, and the mapping also has its own page in the catalog displaying the full set of information that we collect about it. We have quite a long list of mappings in the catalog already, but we know we're missing quite a lot, and this is where I very much like contributions from you. If you know about a mapping that we're missing, it would be great if you could log into the catalog and add it by following the links from the front page. If you've joined the RDA and logged into the website there, you can log into the catalog by typing in a special link on the login screen, following the instructions provided. But otherwise, you can also log in using ORCID, GitHub, or GitLab. As I said at the beginning, we have plans to go a lot further with this. Our long-term goal is to be able to use the metadata interest group's recommended metadata element set to analyze each metadata scheme in the catalog and create a normalized expression of it. And then these normalized expressions could then be used to perform side-by-side comparisons of metadata schemes aimed at humans, and then comparisons that can be used by machines as rudimentary converters. Of course, as Keith was saying at the beginning of the session, some human judgment is always going to be needed to navigate the nuances of a given pair of schemes. But our hope is to be able to generate something that is good enough for some basic use cases and a reasonable starting point for the rest. But as I say, that is some way in the future. If you want to have a look around at what's there at the moment and maybe contribute a mapping that you know about, you can reach the metadata standards catalog from the URL on the screen, or by following the links from our working group page or from the metadata interest group page. Thanks very much.
Thank you, Alex. Okay, if the people that spoke could turn your mics on, we have some questions. And I'll start out with this one. Is X3ML limited to 11 mappings, or can it add mappings as appropriate?
Well, I don't know what you mean by one-to-one mappings. We do need one source schema and one target schema. So in that sense, it is one-to-one. But one element from the source schema can map to more than one things to the target. That's not limited. As long as it makes sense, yes, it can be mapped to more than one. Now, the target schema also can be not one file, let's say. So if for example, I need to use, let's take the example of Sydocs CRM. I have the schema of Sydocs CRM, but at the same time, I can use the SCOS schema for terminology that fits very well with Syndoc CRM. So I can put the two together and use the combination as my target schema. This is allowed and supported by the language. I don't know if that was exactly the question, but.
So if the person to put that in the Q&A box, if you want to turn your mic on and if that wasn't what you wanted, please let us know.
That's good, thank you.
Okay, thank you. Okay, looks like the questions about Cedar are, John has responded to them in the Q&A. So the next one is, how does the automatic mapping to B02 metadata standard work?
The automatic mapping, those are, well, our mapping is Python based, and we have templates for each metadata standard. So if we get an XML in DataSite, for example, our Python program steps in and rearranges the syntax to our metadata schema and then uploads it to our portal. All of this can be found on GitHub. The templates are called readers, and you find them for DataSite, for Dublin Core, for ISO. Yeah.
Okay, and another question, looks like this will be for Alex. Can you offer thoughts on the relationship between the metadata standards catalog and fair sharing?
Well, as you can, I showed you from the timeline, the metadata standards catalog can be traced directly back to the DCC catalog, which is launched in 2013. Fair sharing was launched around July 2017, just as the catalog working group was reaching its conclusion. We have, I think, different scopes. Fair sharing registers a much wider variety of entities, so it's not focused specifically on metadata standards aimed at research data. It also incorporates all manner of reporting standards and vocabularies and so on. And previous to it being fair sharing, it was biosharing and therefore had a tighter disciplinary focus. And I think as I say, for our ambitions for the metadata standards catalog are taking us in a different direction from fair sharing, in that we are looking at using it more as a kind of academic tool for analyzing metadata standards and for providing comparisons and conversions between them.
That's very helpful. I didn't mean it as a trap question. Someone is making comments in fair sharing, but interested me about it is that there might be the potential for exchange of content in an ongoing way between the two, and I was curious if any conversations or thoughts had taken place in that regard.
In terms of sharing, it is something we have discussed in principle, but we're not at the point of being able to put it into practice just yet.
Thank you.
Okay, and it looks like Allison Lister has something she'd like to say.
Thank you. Sorry, I was just unmuting. I work with fair sharing, and I just wanted to add, I put something in the chat saying that we do both have standards, both in fair sharing and in the metadata catalog. And fair sharing also reaches across all subject areas. And I just wanted to add that if anyone had any particular questions related to fair sharing, that I might be able to help with that.
Okay, thank you. So I know that some of the speakers talked about particular challenges with syntactic and semantic conversion. Does anybody in the audience have anything that they'd like to share about that? About the challenges that they are finding right now? And you can go ahead and turn your mic on if you'd like.
At the risk of being incoherent, because it's whatever it is in the morning here, the semantic, I think the semantic part of the introductory explanation could have gone into a bit more detail, because the challenges in semantic interoperability and conversion are pretty parallel to the challenges in syntactic conversion. There are, similarly to what we heard today, a lot of different schemes for making those conversions. And I think I would like to just note the SSMOC, correctly simple specification for metadata. I don't quite have the acronym right, sorry. But does a nice job of specifying Excel spreadsheets for doing mappings in semantic content. But the short answer is, yeah, really complicated. Lots of people have done lots of research on that.
Hello, Jan Dvořák of Eurocris here. Would you perhaps be able to summarize metadata schemas are more and which are less convertible? Are there particular patterns that make them either less or more convertible?
Rebecca, I think you're muted.
Sorry. Would one of the speakers like to address that? We can go around to all of you if you'd like. Anna, you want to start out?
Yeah.
Or Maria?
Can you hear me?
Yes, go ahead.
Yes. Okay. Well, the more generic a metadata schema is, the more interoperable it usually is. For data side is very interoperable. The more, well, yeah.
Okay. Maria?
I think that going from a poor, let's say not very detailed schema to a rich one, it's fairly easy. The other way around, it will be difficult because we will lose information. So you cannot, it's not wise, of course you can, but it's not wise to choose as target a schema that is not very rich, unless you really want it for a very specific application, and then you don't mind, you just want to extract very particular fields from the source and keep this, and that's fine. But if you really want to map everything and to keep the original information, you need to have as target a schema that will be at least at the same level or richer from the source. That's, otherwise you will lose, I think, information.
Thank you. John, did you want to add something?
Yeah, I wanted. Sorry.
No, go ahead.
Yeah. Okay. I was asking myself if we could come back to the other question you posed before this one, the separation between the syntactic and the semantic interoperability. Does it, for metadata conversion, make sense to separate between the two? I ask myself, because with a syntactic transformation, you can, of course, rearrange the elements in an XML schema, but it does not really, I mean, is that useful? Except perhaps that you have a different serialization format then.
Maybe I can blend my answers to both questions. I tend to think of them as being quite separate. The thing that makes a metadata schema or semantics more complicated is if they are getting meaning from their context, which generally means hierarchy, but could also mean cross-referencing. So some metadata schema are infinitely hierarchical or embedded, even recursively. And that is the most sophisticated model and therefore the most unlikely to be mappable into other schema. And it contains implicitly in the answers the context of the parent questions and parent topics. So that's quite, it's exactly what you want if you want really detailed metadata. And it's the hardest thing to work with if you're worried about mapping from one to another. And semantics independently have that same issue, that if the semantic meaning is contextual or even more complex, embedded in a web of references to other semantic concepts, then you will have a very hard time modeling that in anything else. So those of us who are into rich semantics do end up dealing a lot with these rich representations. And I think the linked data model that is becoming much more prevalent in the past 5 years is reflecting the value of that in terms of being able to follow the thread of knowledge about something wherever you may want to follow it. So I think that's a little more the coming place for representing metadata, is in more of a linked data paradigm that allows that kind of ultimate flexibility, web of knowledge and computable knowledge at that.
But just to come back to that hierarchy you mentioned, that you can have a very deep structure in some metadata schemas, but that's done exactly to influence the semantics, right?
I don't know that maybe it is. That's a subtle point. I'm not sure I follow it, but it could be, yeah.
Well, if you have a hierarchy, an XML hierarchy, for instance, you have a, what is it, a parent, parent label,
element, yeah.
contact, element, and you have personal information that goes into that, and the parent element evidently influences the interpretation of the person information below it. I mean, that's how it was intended. Otherwise, they would not have that hierarchy.
Yes, the meaning of the fields below are definitely
exactly
a function of the ones that are above. That's right.
Let me jump in here. Yeah, I think semantics and syntax, although I separated them in the introduction for clarity, are intimately related, and it depends on the structure. So, and Dan and I have been emailing about this on some other thing. In response to the first question, my answer is the target should be as rich as possible. In that way, you're unlikely to lose information, but you will have a lot of missing information in the deployed target.
a little bit open world, of course, in that you can never say everything about everything, and so missing information I wouldn't interpret as a bad thing, right? It's okay to have missing information in a wide open target like that, I would say. Do you agree?
And I just wanted to say there are some other problems that you can come across when you're going from a fairly non-rich metadata scheme to a very rich one, is that you might have problems where the target is so much richer that you don't actually know which slot to put in the general information, because you have to infer that, and sometimes it's possible to infer it and sometimes it isn't, and you could end up losing information, not because the information isn't there, but you just don't know which slot in which to put it.
Jane, did you have a question?
No. Sorry. Just great. I joined late, but just great to see all this work happening. Just fantastic. Sorry.
No problem.
So, if I may comment
Yes.
on the conversion and what is easier than others, I think what I found out is that if metadata standard is well documented, it's easier to create conversions. And also, if the metadata standard has an active user community, and then it's probably easier to find the solution.
Okay. Any other questions by attendees that they want to ask the speakers? So one I'd like, if some of you could comment, is what are some of the best practices, do you think, for creating converters? Alex, do you have any thoughts on that since you've been doing this?
Well, again, I think as was mentioned in the presentations before about, I think from Dan's presentation, making sure that there is a transparent amount of information about the provenance of the mapping, about the responsibility, about the context for which it was created, and some commentary on performing it, because there may be subtleties according to the information that is being pulled out, whether the use case in mind was looking for particular bits of information and not so worried about others, which might limit its usefulness in different use cases.
I would second that. What we found out in SHOC is that there are a lot of orphan conversions around, and it's difficult to find out who created and if you are allowed to use them for your own use case.
Yeah, this fit for purpose is extremely important to also document. Something that works for researcher A might not be of interest at all for researcher B, even if they need the same kind of mappings.
Maria, did you have anything you'd like to add to that?
Yeah, I would agree also on what Dan said. it is a matter of collaboration. I don't think the mappings can be done by just one person sitting on a on a desk and doing this. It is you need to have involved the community that has the data and knows what it is about in order to do an appropriate mapping, and involve everybody that is somehow involved.
John, did you have a comment?
No, nothing to add.
I think it's, who were you addressing, John or me?
Oh, I'm sorry, John.
Yeah, no, I'm good. Go ahead, Don.
Yeah, I think it's the word collaboration is well chosen. We need to be able to gather all these mappings or conversions that are out there and allow users to document them in a proper way. So, for instance, if a conversion has been used successfully in a certain context, that would be good to know. Also, if it was not successfully used in another context, that's also good to know. So kind of annotation option of such a registry would also be very helpful, I think. Although you have, of course, to be careful. Not every researcher that creates something and uses something is willing to share his experiences there. So maybe it should not be obligatory, but it should be inviting.
Okay. I think I've shared all the slides in the notes. I'd forgotten to change permissions on one set, but if you could let me know which ones are, if you can't access them, please leave a note in the notes and I will make sure that I check it again. And we didn't do breakouts because they're a little difficult to handle on this particular platform. So I switched it over to question and answer. So let me see, I'll check the Q&A one more time to see if we've gotten to all of them. Okay,
Go ahead.
Go ahead.
I was just going to say something I might clarify while you're checking is about the bioportal versus Cedar versus Cedar can be deployed as a standalone platform and configured as such to talk to another ontology repository that's driven by the Ontoportal or bioportal software. So there are some people who are exploring that, and there's an embeddable editor as well that is some people are looking at for using in a similar way. So there are a lot of different configuration options there for people who are thinking about whether they want to include Cedar in a larger ecosystem. And feel free to contact me for details there.
Okay, so I think we have time for one last question. So this one is, oh, they disappear. It's really fun. It had to do, I really like the question about using schema.org. Okay. What role do you see for schema.org as a mapping tool for metadata schemes? Who would like to address that one?
I'd love to start it. I would say schema.org is a broad purpose, a broad brush metadata schema, even in its narrower forms, and is very useful as something for general cross mappings and access via the web or discovery via the web, but is not at all a precise schema, and therefore is not. It can't be used in some of these more rigorous approaches that we've been talking about.
Keith, did you have an opinion on that one?
Basically the same answer. Schema.org is quite useful at a general level, but it isn't rich enough to act as a basis for interconversion of any of the schemas for research assets that I have seen.
Okay, Mari? Your photo popped up. That's why I'm asking you.
Oh, sorry. No. Unintentional.
Okay. Well, I think we've reached the end of this session. So I'm going to check all the slides one more time just to make sure. You may have to refresh that particular page because I've made some changes. And I wanted to thank you all for joining the session and also for the notes. If you have some questions that weren't answered, please put them in the notes and I will get them to the panel and put the responses back into the notes. And thank you, everybody.